Good morning, everyone. Today we are going to discuss about the interview questions of VLSI DFT. My first question is, what is the difference between timing and no timing simulations? No timing. Basically, no timing simulations are done to check the design setup related errors. In this, we test for a zero delay and unit delay conditions. For this, we consider SDC, Synopsys Design Constant File. So timing simulations are done to check whether our design is able to meet all the timing constraints properly or not. For this, we will consider SDF, standard delay format file, which contains the delay information, which is provided by the STA team, static timing analysis team. My next question is, what are stuck-at and transition faults? Stuck-at fault model tells us that a particular net or a wire is either stuck to 0 or stuck to 1, which is connected to ground or VDD. So transition fault model falls under the delay fault model. So which tells us that a particular node is able to make a transition from 0 to 1 or 1 to 0 at maximum operating frequency of the design. The two possible faults are slow to rise and slow to fall. Next, what is the difference between the verification and testing? Verification is done to check the functionality of the design. So it can be done at RTL level only. So verification is going to check the functionality of the design. It requires more time, more number of test vectors are required for the verification. In case of DFT, it is easy to detect the manufacturing defects by adding an extra logic to the design to attain the controllability over the design. So it requires less number of test patterns. Extra logic is added, less time. So it will check the correctness of the design. DFT will check the correctness of the design. Verification will check the functionality of the design. Next, do verification is done at RTL level for testing the functionality or not? Yes. Functional testing is done after the RTL stage. What is setup and hold? Setup time. The amount of time data and the synchronous input must be stable before the active edge of the clock. It is defined like required time minus arrival time. So setup time is always positive. Positive slack is good for setup time. So next one is a hold time. The amount of time data at the synchronous input D must be stable after the active edge of the clock. Data must be stable after the active edge of the clock. So it can be represented as arrival time minus required time. Here in setup time, data is delayed. In hold time, clock is delayed. So this can be fixed by reducing the clock frequency, and the hold time that can be fixed in two ways, by adding the buffers in data path or adding the lockup latch in the data path, Q to SI path. Q to SI path, we can able to fix the hold time violations. We can observe the hold time here, red color. We can observe the setup time here. Next, what are the scan violations you faced and how did you debug them? I have faced the uncontrollable clock and uncontrollable set reset violations. When all the flops in the design are not controlled globally, then we will get these violations, because for a design to DFT ready, we should have a global controllability and observability. For debugging these violations, we need to check the DFT DRCs using the command check DFT rules. Once we have known that there are internally driven clocks, are there two major ways for getting ways of getting back to the controllability, auto fixing the issue using the command fix DRC violation. So doesn't we'll use command set test logic on. Insert a test point so as to bypass the logic while testing. Instead of adding mux as a test point, can we fix it by any other method? Yes, we can fix it. We can fix it by using the AND and OR gate based on the design. So if we insert a test point by keeping always test enable is high, then do the functional verification affect or not? Yes. It affects the functional verification. We can't perform the functional verification when test enable is high because we have to toggle it 0 to 1 and 1 to 0. What are the outputs of scan insertion? So scan inserted netlist, SPF pin assignment file, scan def file, scan SGC, which contains synopsis design constant file. It contains the false path and multi-cycle path information. So what are the inputs of atpg? So atpg inputs are libraries, scan inserted netlist, SPF pin assignment file, SDC standard synopsis design constant file which contains the false path multi-cycle path information, SDF standard delay format file. It contains the net delay, cell delay information. This can be considered while generating the timing patterns at speed patterns. So what is a clock gating cell with AND gate and why we go for ICC? So clock gating is a common technique for reducing the dynamic power dissipation by regulating the unwanted switching of the clock to modulus by a clock enable signal. So clock gating cell, if the some particular logic in the design not required, not in functional, then we need to reduce the dynamic power. So that this can be done by disabling the clock to that particular block. So this can be done by adding a AND gate there. So if you go with an AND gate, then there will be a glitch. Chances of getting glitch if enable signal is high, the middle of the clock. So there will be a chance of getting glitch. So to avoid that issue, so we are going with the latch with the AND gate. So that is called ICC integrated clock gating cell. So this latch will provide us some delay so that we can able to avoid the glitches in the ICC clock gating cell. What are the violations you have seen in ATPG? Automatic test pattern generation. Violations we have seen. I have faced S1 violation which is related to scan chain tracing. So if the ATPG tool is unable to trace the scan chain completely, then it will throw an error. Normally in Tessent we call it as a T. So if the right libraries are not read, then there is a chance of getting these violations. Also, if the clock pin is not mentioned properly, we'll get these violations. I have also faced the violations related to block boxes and memories. So we should update the memory libraries and block box libraries to get rid of these violations. What does the test procedure file have? Test procedure file contains all the scan information of your test ready netlist. It contains the number of scan chains, number of scan cells in each scan chain, the shift clocks, capture clocks, and also it contains a setup, procedure for shift, procedure for capture, procedure for load unload. So all these information we have in the test procedure file. So this can be read in the during the ATPG. So I'm going to end this lecture to here. So we'll continue in the next video. Please share and subscribe my channel.